Assalamualaikum warahmatullahi wabarakatuh, and good evening, especially to our lecturer, Dynamics, Dr. Faus. Okay, first of all, I will introduce myself. My name is Muhammad Fidaus, and my partner.
My name is Hazal Fikri bin Kamarudin.
And my name is Muhammad Khairul Iqbal bin Nordin, and I will solve the question 1A to D.
And mine will be question 2A to D.
Enjoy the video.
Thank you. Okay, today I want to explain the question from the question 1 part A. This is the question for the part A. This is the ball and this is the head ball from the ground. And question 1A, we need to sketch the free body diagram. First, we need to sketch ball. And the downward force is mass and gravity. And the second force is VB. And the third force is N. And for the B question, we need to find the velocity at the point B. At the point B, the formula is sum of kinetic energy A plus sum of UAB equal to sum of kinetic energy B. The formula is 1/2 m VA square plus m GH equal to 1/2 m VB square. And the mass, we can eliminate this. And for the VB, we need to calculate all, and the answer is this: 7.004 meter per second. Okay, we continue for the question 1C. The question is to calculate the distance from the wall of the ramp at B to where the object strikes the ground. The formula is for the horizontal x component, xc equal to xb plus vbx tbc. The xb we get from the graph is equal to 0 plus vbx is we get from the previous question, and we get is 7.004 times tbc. This is for the equation 1. And for the vertical component yc equal to yb plus vby times tbc minus 1/2 g tbc square. And from the yc, we get from the graph is -1 equal to yb we get from the graph before is equal to 0 plus for the vby we get 0 also, and times the tbc minus 1/2 times 9.81 times tbc square. And we calculate that tbc is 0.4515 seconds. This is for the second equation. And lastly, we need to sub equation 2 into equation 1, where D equal to 7.004 TBC, and we get before the TBC is 0.4515 second, and we conclude that its time with 7.004, and the distance we get is 3.1623 meter. Okay, we continue for the question 1D, where the question 1D is to compute the speed at which the object hit the ground. This is the formula for the principle of work done energy. And we assume that TA is 1/2 m times VA square plus mgh equal to 1/2 m times VC square, where the m we can eliminate in the both equation, and we substitute the G is 9.81 times H is 3.5 meter equal to 1/2 times V2 square, and we get the V2 square is 8.2867 meter per second. Okay, that's all for me for the question 1 part A. Thank you.
Assalamualaikum and a very good evening especially for my lecturer, Dr. Alfaus. Okay, I will explain about the part B, question 2. So this is the question 2 part B. As we can see here, this is the FBD. So from this FBD, the object is slid down due to gravity force. It passed through B and fall to the point C with velocity B, and then it will bounce to point D with velocity C. So the height between point A to point B is 3.5 minus 1 meter, which is 2.5 meter. So to analyze the question A, so we have here, due to the object is released from rest at the beginning, we use this formula, which is the principle of work energy. So we can get the initial velocity, which is velocity VB. We calculate we substitute all the mass, the gravity, gravitational force, the height that we talked about, and then we have the VB, which is 7.004 meter per second. And then by considering the vertical motion of the fall, we need to use this formula to calculate the velocity C at y-axis, VCY. From this equation, we substitute all the value. For AC, we use negative 9.81 because it is acceleration. So SCY minus S1Y, 0 minus 1. So we got the VCY is negative 4.43 meter per second. So from this question value, from what we have in the data, this is the coefficient of restitution, E equal to 0.7. So this is the formula to calculate the VCY2. So we insert all the value 0 for VY2 minus VCY2. So we have to find the VCY2 minus over minus 4.43 minus 0. So we have the velocity for CY2 3.101 meter per second. Okay, so therefore the rebounding velocity of the object at C is VCY 7I, which is x axis, plus 3.101 J is the y axis, meter per second. So we can find the vector direction. So square root 7 squared plus 3.101 squared. So we have the magnitude, which is 7.66 meter per second. So move on to question B. So question B, to find the height, we use kinematic equation, which is the vertical motion of the object after it rebounds from the ground. So from this calculation, we submit all the value, okay, and then we get the height, which is 0.49 meter. That's all. Thank you.